Okay. All right. Yeah. So thank you very much for having me. And obviously, my main kind of message here today is that AI obviously has in some or many respects failed the expectations that many of us have now and in the future, and obviously on terms of resources and expectations. So the control aspect here is that the architecture and the algorithms can be vastly improved over existing algorithms in terms of inferential insights, cognitive AI, and so on, in order to actually attain artificial intelligence at a huge lower cost to the environment, to the planet, and obviously to us, the users, where basically transparency is embraced with explainable AI. At the moment, obviously, the big tech, as you all know, is forging ahead with standards and kind of imposing that on society, where ultimately the embrace of the fathers of AI, notably Stephen Hawking and so on, did address some of the issues and concerns, definitely in terms of environment, humanity that we live in, and the planet and its resources and sustainability, that are now being questioned by many, many practitioners, and obviously these caveats are being raised all the time by statisticians, by many other forms of critique, philosophical and I would say theoretical. But at the same time, there are huge, huge benefits. So I will do a couple of quotes just to embrace the motivation and empowerment, because we are living in very exciting times. A lot of these philosophers and academics are not witnessing what we are witnessing now, which is obviously the twilight of AI in terms of its fruition in the future. So if we obviously set some kind of roadmap, what we do in the next 5 to 10 years will ultimately affect how AI will look in the next 15, 20. Will that work for humanity? Will that be used in accordance with the Zen laws of nature and so on? Or it will be compiled by big tech, security firms, which will make or transfer even the black box into a dark cloud where all of us will have a limited capacity to understand really the algorithms that are running most of the internet, security firms, and so on. So it's a kind of a big thing, but at the end of the day, just to make you kind of think about it. So don't ask what AI can do for you, ask what you can do for AI. Obviously that's taken from John F. Kennedy. I think humanity is very selfishly trying to extract anything it can out of AI. But in terms of giving something to AI is obviously another story. So bearing that in mind, ethics is extremely important. AI ethics transcends globally and obviously polarizes each segment of society from the poorest to the richest. AI cannot be just given to the richest countries which have developed the fastest. It has to be kind of in tune with balancing that with poverty-stricken countries in Africa, which are just developing. And I think AI can be really used in that direction to propel growth and reduce poverty. But at what cost? Will the forefathers of technology make that transparent, accessible, to rebuilding Syria, to reducing famine by making AI efficient water control systems? Will that come into fruition in the future? It all depends, and it depends on very people who actually make those decisions, and not so much on the ever-going climate change, which obviously is going on without really us having too much to do with it. Everything is very cyclical. So that's basically my roadmap here. So AI is not a drop in an ocean, it's the ocean of knowledge evolving in a drop. And that's taken from Jalaluddin Rumi, which obviously his original quote was, "You are not a drop in the ocean, you are the ocean in a drop." And obviously that is kind of embracing exactly that humanity should be looking internally really into the challenges and really the resolutions that we can obviously foster from that. The British philosopher Alan Watts obviously commented extensively on the troubles of the planet in terms of limited resources. And really, I think AI has a chance to recoup the bad image, obviously, of machines in many respects. It can definitely be used beneficially on a global and local level to foster cooperation, to foster collusion within the research and development side of globally of any country that is obviously wanting to embrace that change. It doesn't have to be just with the richer, more developed countries, and all countries and people should be welcome into obviously embracing that. So I think we cannot forget that the planet belongs to its citizens, which obviously are humans, us in general. So we have to respect that, yeah? And I think some meditation goes a long way. I think meditating on that is obviously something that is inward looking, and like AI here, you have to really foster that in its purity in order to get the most out of it, really. You can look at it in a very short-term point of view in a selfish way, but in that respect, many solutions, global solutions, will be really not available in the next 10, 15, 20 years. So let's just bear that in mind. I think, yeah, as Pawan beautifully said, only humans felt unhappy in questioning the meaning of their existence. Birds don't do that, trees do not do that, animals don't do that. They just live, they just are. So maybe there's something wrong with the way humans are approaching AI as a new technology, and have not really come to realize that the future generations will really inherit what is left there in terms of legacy. And the legacy will be really left by the technological legacy. Will it be more skewed towards technical debt? Will it be more skewed to more pollution and double standards, which obviously exclude a lot of countries for either political or other bias? I'm not sure. You know, this is a very big thing. At the moment, I think most organizations are grappling with many challenging aspects like security, etc., to be able to obviously present some vision of what can be achieved with AI. Yeah. So I think AI really was invented, or the methodology or the algorithms were invented a long time ago. Really, it's just been the propagation or the acceleration of GPUs and TPUs through federated learning that has actually made the mathematics work. So really, in terms of that, the mathematical genius of many practitioners globally was set maybe as 1980s, really. So that is open obviously to bias. If the big tech has the capacity and the capital to make AI work mathematically, then really we are losing the ownership to say or to focus many AI greener solutions, which obviously are reducing the huge power debt and technical debt of sustaining the infrastructure built on AI at the moment. So really, there's a lot there really to take on board, and even my father worked and was working with professors in in Warsaw, and also later in America. And all these foundations were really realized when a lot of his work and his professors, Professor Findeisen, were used more in a tracking error capacity in terms of missiles and so on. So there is that kind of gap between the accountability and what we do expect and how the reality obviously is set. So that is just a reminder of some Cold War ethics that really were also responsible for building a huge embrace of technology into maybe very, very dark areas, which obviously has carried on in many ways. So I don't think the primary objective was to safeguard the planet, but to play out some kind of standoff and so on. So we do live in challenging times, and notably Gary Marcus, obviously one of the guys there of AI, he put up a paper in terms of proposing a new novel approach to AI, which obviously can be summarized in hybrid knowledge-driven, reasoning-based approach centered around cognitive models that could provide the substrate for a richer, more robust AI that is currently possible. So obviously this is a great critique on the big tech, on what is being built, on the technical data is being built, on the usage of electricity that is being built at the moment by big tech, where really there are other solutions available, but they are kind of discarded in terms of being favored for more kind of statistically inefficient solutions to architecture and technical solutions. He quoted some people. Immanuel Kant: the capacity to be affected by objects must be necessarily precede all intuitions of these objects, and so exists in the mind of a priori. So really, who has control? Do we humans control AI, or does AI control us, or is AI susceptible to human bias and so on? Where's the justification where the AI is blamed for human error, or AI is hacked by humans and then the scapegoat of kind of massive proportions, which in the age of fake news and manipulation can be easily done, really. And so there's great expectations for AI to become more transparent, for people to be more comfortable what it can do for the planet, rather than from the government side or from a kind of more authoritarian regulatory consensus, which is being forged in many countries, even so in Asia. And Bitcoin obviously is a good example of that, where that technology is not really being adopted due to many reasons, and a lot of those reasons are not anything to do with the benefits of society or ease of society, purely on grounds of regulatory walls and tariffs, and kind of scapegoating that for its unreliability, and treated as a threat for other institutions in terms of its stability, volatility, and other practices, which are not really 100% correct, or even through people's experiences, but that seems to be sometimes the consensus. So William James said thought is a kind of algebra. So in terms of its purest AI theory, AI will basically learn algebra and reason enough to confirm that the algebra is correct, and the models are being basically validated in terms of their robustness. And when it comes to robustness, there are many definitions of that, which I'll come on to later, but obviously each model is not perfect. So an AI model will never be perfect, but some models will be correct, and some models will be more correct than others. So by setting up a global think tank of correct design patterns for AI globally, which are not just basically reflecting the huge potential benefits for big tech and the profit margins, that obviously transcends into greener areas of sustainability and accessibility of that AI for even, as I said, rebuilding war-torn countries. As everybody knows, technology can accelerate that massively and even reap knowledge and rewards globally to many areas of less wealthy society. So something to bear in mind. Then we come to statistics. Many of these modern day AI models are built on statistics, and obviously that is just one side of the equation. There are many solutions which are non-statistical, and they are coming into fruition. In many ways, artificial intelligence as it is now is not the end product. So many control algorithms which do not rely, for example, on statistical distributions, and use lower technical debt, a better usage of electricity, more federated, decentralized learning based on AI game theory, would certainly add a lot to advance of greener AI. In many ways, they are a threat, to general statistical, obviously, models, right? And results, the results of many AI-driven statistical models are less than perfect. We are going to sort of areas of reinforcement learning on a global scale, a decentralized kind of federated scale, where there are obviously limitations to that. And in order to process that, you would need to have a sizable and expensive GPU, which you would have to buy from NVIDIA or other sources, and that is positively correlated to the price in the last 5 or 10 years. So there are other solutions, and I think they burn really a lot of electricity, which obviously is scarce. So they're not really too efficient in that resource. And obviously, the expectation of AI is being overshadowed by these hidden costs, by these hidden technical costs in terms of architecture and models that are used for solving the algorithms that other models can obviously be employed and deployed that can obviously be better used for society. So as you know, roughly a decade ago, one of our geniuses of our time, Stephen Hawking, was really pondering the facts that he might not be around forever, but humanity and evolution of AI will. And he picked up on a lot of kind of things that transcended many boundaries of society and captured people's imagination. Lately, obviously, with the coronavirus, less is being obviously paid to this kind of long-term vision of how this can obviously benefit society, and obviously the dangers more to do with the short-term obviously crisis that we are experiencing at the moment. But obviously the evolution of human beings has overcome many serious crises, and this is no any other. As long as humanity can learn from that, then it can prosper and retain that knowledge in order to really solve similar problems in the future. And I think this is critical. So the potential benefits of artificial intelligence are really concentrated on research, on global research, and this global research can have many multidisciplinary fields. It doesn't have to come from the big tech. So I mean, it's very trendy to work for big tech, but it's also commercially driven companies which which really maximize their profits by even producing chips and other microprocessors in poverty, well, no, lower wage outsourced areas in India, Pakistan, and other places where that transfer of wealth is not really beneficial either in prevention of nature or even redistribution of wealth. So we are experiencing through globalization a greater polarity of inequality measured by any index. And even surprisingly, China, for all its criticism, can be attributed to having a fairer society than one that is developed in Western countries. So I think that is something to bear in mind. And certainly my father, no longer with us, but he had many students from China which came and studied in Birmingham University, where he was a professor, and they were very open for knowledge. We were very open for knowledge. We were very different. The expectations were different, and all of them went back to China. All of them went back to kind of take that knowledge and build, I would say, many applications in terms of infrastructure and so on, which obviously were used in a very positive capacity to embrace obviously the huge expectation of consumption of energy in China in the future. And I must admit that some of the solutions that China has come up with are totally based on AI and are totally homegrown, but based really on a hugely successful development of these infrastructure, which is obviously benefiting the people, while proving to be very sustainable in terms of fostering nature and really preserving the ecosystem. So from many of these solutions, and that is really something that we can learn from as well. So that is just like a side point. But yeah, I mean, Stephen Hawking, he was I would say he was curious, yeah, but he was very obviously also worried that really humanity will just look at the short-term gains and forget about the larger picture. So obviously that is something that needed to be addressed. Is it being addressed now? Not really, no. I think we are forgetting very quickly how we live now. We forget very quickly, if we haven't lived through these lessons, that maybe the corona will make people remember that we can live without the reduction in pollution. People are using less of energy consumption to live, and obviously that's a good thing. If AI can propel this and give people the accessibility and trust that the information, the security, the ethics are met globally, then I think that's a wonderful thing we can all aim for. Will it happen? Maybe not in my lifetime, but maybe if you live forever, you can maybe write a critique about it. But certainly, professors like Francesca Rossi stated that it's very important that everybody knows that AI researchers are seriously thinking about these concerns and difficult issues. And I think when it comes to intelligence, which obviously can be used as a watchdog to look at big tech on a critique, look at the government level on a critical viewpoint, then really the devil is in the detail, and ultimately the AI is no different. Yeah, AI is no different. So there are many short-term concerns and obviously long-term concerns. Will humanity be exposed to basically the latency of actually doing mathematics by themselves? Will automation, AI, will kind of finish off the kind of average person's perceiveness of you know, actually adding numbers in their head and doing simple calculus, and which also was fostered in many Soviet republics where I would say the software development was much slower, so the reliance on calculators and so on was so much less. So people were actually doing a lot of these integrals and derivations, not through computers, but on paper. And if the mathematics was correct, so was the outcome. And that is really the legacy. I must admit that statistics has kind of overshadowed a lot of these solutions or pigeonholed them. And I think we have to be very careful not to really fall in love too much with that kind of simplicity. So therefore, Gary Marcus pointed rightly that robustness, recurrentness, and recursiveness should be at least the three pillars where AI will be critically assessed in terms of its model validation. These are pillars which really act in kind of linkage with each other, like a graph. They support each other sometimes one is more predominant than the other. But just to give you a lowdown, that the biggest kind of challenge at the moment for AI is reinforcement learning. And in terms of the long-term, short-term memory capacity of transformers, of many kind of image recognition, NLP, they are heavily linked to technical debt and huge consumption of electricity. While the benefits obviously is kind of not measured in the right metric, but that doesn't have to be that way. I think more robust systems out of control can proportionally decrease technical debt by 9/10 in some ways, and that is a huge thing to take away, really. Some calculations can be done on my computer which doesn't have to have a huge capacity, and I can use TPU, federated learning, in a fraction of the capacity that Cloud, Google, etc. can do that, and certainly less of a cost. But well, obviously that is, you know, something that academics and people who have programmed neural networks from scratch using, you know, closed information loops instead of open information loops for image recognition understand better than others. So there is no kind of there's no source of that. There's a lot of software development with Python, but Python is just a notebook. It's just a compiler. The essence of all of this is really done with mathematics. So if you really try to do a simulation using statistical distributions, you would need roughly from 100 to 1,000 times longer to process the correct solution that can be done by a deterministic, robust, recurrent, recursive algorithm. Can this guy tell you that this is something that can be attainable? Well, my notion and notion of a lot of academics is that robust intelligence can definitely be an added value in terms of that. When we say control systems of robust, we mean stability that is maintained by the performance specifications for a specified range of model variations of uncertain range. Basically, that is a way of dealing with uncertainty. Uncertainty, obviously, of what's coming next, and obviously that is part of cognitive AI and reinforcement learning. The way that current AI reduces that is by basically hammering huge technical debt on a 50-layer deep neural network to just basically copy a copy of 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 a copy using activation statistical distributions and come up with something very, very simple, if not basically Belial. Yeah, so there is certainly a lot more room there to have a look at that. So in meaningful ways, robustness really is a control algorithm. It makes a reference to a specific uncertain range of stability. In order for stability to be met, you have to have a recursive, which means really a sustainable horizon range, not just on t+1, but t+2, t+3. So there has to be predictability or predictive indicament of that deterministic model. All these models are based on mathematical equations with very simple structured statistics, and obviously they are not so difficult to construct. A lot of them obviously rely on I would say with the demise of the Soviet Union, technical debt of knowledge, which was obviously to do with derivation of these functions. What really changed, or which came to fruition, was really the neural network. The neural network, in its deterministic way, can really accelerate due to its simulated stochastic gradient, a much more efficient way of changing the weights of the neural network in terms of its decision-making process. And that is something very, very unique. That is where the decision comes from AI, in terms that the data structure is learned or through NLP or image recognition. It's then processed by even a genetic algorithm through mutation, through elitism, through even pseudo-random sampling in order to reduce the cost function error through maybe a 10-minute calculation. So if somebody tells you they need 10 hours to process something, I'm not sure if that's correct. I don't think that is really how the theory works. I know because I've done it and I've seen it in action, and it can obviously transcend. Well, the limitation of that theory was to really make structural decisions based on the ongoing basis, which Marcus was talking about. When the environment changes, which it does so often, can AI deduce that inference through robustness, through recursiveness, through recursion in its architecture, in terms of its sustainability of predicament, and learn before the change happens based on its steady state proposition of what has happened, the best outcome that can never be a human AI decision process. And obviously that has been proven while on a bigger scale of technical debt with beating chess champions and champions of other kind of games, where basically they can see not just 50 or 100 moves ahead, but maybe even 2,000, and come up with the best solution. And I think that is really where this can be really beneficial. And obviously that can be used, one, to reduce technical debt, two, to become really federated, and the local solution can be really, in terms of playing sub-games of sub-agents, it can be obviously attained on a global scale. I think this is where really a lot of question marks over how AI is looking today came into fruition. And the solutions are unlimited, really. They're unlimited. So it's really for the capacity. One of obviously the critiques was, can you make AI explainable? And yes, you can, but you need to make it more obviously transparent and less opaque, right? So in terms of that, the black box needs to become more of a white box, and even compilations like TensorFlow, which use graph technology on edges, is something that is going in a direction, but it is actually losing itself in the technical debt and affordability of making that accessible or business case users for the planet and as such. So the big tech is not really sharing that with the rest of the planet, and that's really my point of view. So with great power comes great responsibility. It's not a question if AI can be trusted, but if humans can be trusted with AI. And I think the way humans have shown so often, the way they treat the planet, which obviously you would think is their bread and butter, sometimes they lose themselves in that, and even the extinction of, or near extinction of, some species, some even the Red Indians in America, or Aborigines in Australia, is a kind of a tough reminder, yeah, that sometimes really, my way or the highway is not the best approach in many ways. So yeah, the derivation of this theory is very, very simple, and it goes back to the paper, rock, scissors game, which was later extended to the paper, rock, scissors, fire, water game in China. And really, it's basically, a graph. It's basically based on the multi-agent graph, edges and causation of the fire beating paper, the paper beating the rock, the scissors beating water, etc. But ultimately, because it is used by humans, water was used less than fire, and fire was used the most. So sometimes the human bias is really in the humans and the way they would use AI in the future. And I think that is a huge
Thanks,
challenge as well.
Marcin. I'm sorry I'm interrupting in here. We we are conscious of time, and yeah,
That's it.
I'm really
That's it.
thankful to your talk, and it has
That's
been
it.
so insightful. I'm sure people
That's
must
it.
have loved your phrase for Rumi, that we are not an ocean, we are not a drop in the ocean, but a ocean in a drop. Definitely, it took the heart away, definitely. And I can say, we are looking forward to more greener AI models, and how explainable AI is going to be so important. The collusion of AI agents. We as humans, we need to safeguard our resources, because we are a part of this nature, ultimately, of its elements. We are a part of all the different galaxies into it, and how we need to protect it for our next generations. And as you rightly mentioned, AI is going to evolve, it's going to be there, but can we embrace it in the right way, making it more sustainable, in the right green direction, we can say, where it benefits us, but in a sustainable manner, I think. Thank you so much, Marcel.